Hello everyone, welcome to our pre-calculus lesson. This is lesson 25 and 26, Introduction to Describing Datasets and Graphical Representations of Data. So these are basic statistics. So let's look at the agenda. What is statistics? Statistics, methods and applications, population, sample and variables, describing data by tables and graphs for qualitative data and then for quantitative data, then in-class practice and homeworks. So first of all, we will just go for some basic methods and definitions that is related to this basic statistics course. Then we have some representation system, and you may see it some larger number of information here, and this is 2+ worth of material. That is one reason for that. So what is statistics? Statistics is basically a method for collecting and analyzing the data. Collecting and analyzing the data. And this collection methods and the analyzing methods actually involves in these three different steps. First of all, designing for the research studies, designing, then description of that data, summarizing and exploring the data. So the description process, like what we will do, how we will explore it, how we will take the data, etc., all this thing. Then inference is making the prediction or making the decision about the data. So these are the three steps for or methods for the statistics. And what are the application of this statistical? This is the same thing that we have seen in the previous slide: design, description, and inference. And then consider the following problems. These are the problems where we can see the application of statistics. Suppose agricultural problems, medical problem, political science, economics, technical problems, etc., etc. So let's say in agricultural field, if we go and if we want to study like which fertilizer is better or which fertilizer is productive, then we need to go to the field and try to get the information of what is the production after using this fertilizer, and then what was the production before this fertilizer. Then we can compare both of them, and if we see that this fertilizer is helpful, then we can draw a conclusion that this fertilizer is helpful. Or if it is not, then we can say that we have to avoid this fertilizer because this is not helpful. Same thing goes with the medical problem. Let's say you try to take let's say when we have fever or any other disease, we go to the doctor, and doctor actually knows how many milligram of that tablet or capsule we have to take. They write it let's say 50 milligram or 100 milligram or 500 milligram, or even in some tablets only 5 milligram is enough for our body, and doctors know that. How do they know that? Because they do some these experiments with the real people, and they try to give different doses to different people, and they see what type of doses actually works better, or which one is most smooth for diseases, different diseases. So this is how they know it. Okay, same thing goes with the economics, technical problems, political science, and etc., etc. Everywhere we can use this statistics. Okay. Now the definition: population and sample. Population is the total amount of all the people. That's the population, or all the things that we are trying to study. Sorry, all the things that we are trying to study. This is called population. All the entire thing. And sample. Let me give you an example. Suppose we want to study how many students in AOW they like some burger at lunch on some specific day, let's say Friday. So for Friday lunch, how many people like to have burgers who want to study? Now in AOW we have about 900 students. So they are the population, 900 students. But we cannot go and ask all the 900 students to take their answers. We can just choose 50 people or 100 people at best. Then we can ask them, what would you like to have in your lunch for a Friday? Let's say we want to study it for the lunch Friday. burger. So we can take the information from them, and then we can draw the conclusion. Okay, this percent of people likes to have the burger, and of course we have to give some other options. Let's say if we say that how many of you want to burger, then if there is no other option, then it's no good. Suppose burger, hot dog, and some pizza. So how many people like to have the burger? How many people like to have the hot dog? How many people like to have the pizza? Then we can understand, okay, what type of food the students wants the more. Then we can provide it in that way. So then these 50 or 100 people from whom we are taking the information, they are the sample. Okay. Also, this is important that we do not take all the information from one group. Suppose from on these 100 students, we cannot take only from Access Academy. We have to take it from UG4, UG3, UG2, UG1, pre-access, access, and we have to take the information from all the students. Let's say from each group 10 students, 10, 10, 10, 10 from everywhere, or 20, 20, 20, 20 from everywhere. Like that, we have to take the this is why this sample is taken from here, this sample is taken from here. Not like all the sample is not just from this portion. We have to do the random sampling, randomize the sample. We have to do it. Okay, so sample is the smaller group, population is the entire selection or entire study group. There's the population. Now we have the variable. So the variable is basically things that varies, things that change. That is the variable. So that is the variable. Variable is the change. Let's say for human, we have height, weight, number of siblings, sex, marital status, and eye color. These are different from people to people. That's why these are variables, because they can change. They can change. That's why they are variable. And variable can be of two types. One is quantitative, another one is qualitative. Quantitative means they are numerical. The answers are numerical. Height, 5 feet 5, 5 feet 10, or 6 feet, or only 5 feet. The answer is numerical. Weight, let's say 100 kilogram, let's say 80 kilogram, 60 kilogram, 70 kilogram. Then these are answer is numerical. That's why these are the quantitative data or numerical. Qualitative data, these last three, sex, marital status, and eye color, these are qualitative data because we do not give them any number. What is the sex? This is male or female. So this is not like number. This is marital status. Are you married or not married? So basically these are not number. These are non-numerical information or categorical variable. These are. So these two kinds we have here. Then from this quantitative data, quantitative variables, we have another two types. One is called discrete and the one is called continuous variable. Discrete variable means, let's say if I ask you how many siblings you have, your answer will be 3, 4, 2, this kind of something. And your answers will never be 3.5 siblings. Always it will be 3 or 4 or 2, some whole number. So this is discrete variable. Continuous variable is if the answer can take the decimal number, then it is continuous variable. Suppose what is the height or what is the weight, then it will be continuous variable. And if you have more precise machine for measurement, then actually your answer will be more accurate. So accuracy, we can measure it with random accuracy. Decimal number comes for continuous variable. Discrete variable, only whole number comes. Okay, then it is discrete variable, then it is continuous variable. Now how to describe this? How to describe it? So this is qualitative variable. How do we qualitative data? How do we describe it? We can describe it in two ways. One is this bar diagram, another one is pie diagram. So for 40 people, these are their blood groups. So how many people have O? How many people have A? Like this. So we can represent it by some bar or some pie chart like what is the percentage here, how many people have A, what is the percentage of that. Then we can, this whole thing is 360 degree, then we can take the proportionately we can divide it. This much people have blood group A, then this much people have blood group O, this way. So we can just do it this way. Suppose this is 16 people O, and we know that total is 40. That means for 40 people we have 360 degree total. So for 40 people, for 16 people, how many degree we can find out that way. Then we can color it, or we can take that portion from the pie chart. This is pie chart. Now for quantitative data, one very useful way is to work with the histogram. So work with the histogram. And how to do it with the histogram? Let's look at the example. Actually, we have a lot of data here. Age of 102 people. Suppose in some sample size, in some place we are taking this study, then some people said, someone we asked what is your age, they said this 34, someone said 67, someone said 40, someone said 72, and these are their answers. Now we need to make a chart first of all to make a histogram. From data to frequency table, this is the frequency table. So first of all we make some class here. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have made 10 different class. This one, this one, this one, this one, this one, like that. This is not mandatory that we have to make always 10. Normally it is from 5 to 10. This is better. If we have a lot of data, then better is 10. If we have less data, then we can just come to 6, 7, 8, like that. If it is below 5, then it is too less, and if it is more than 10, then it is too much of class. Because if we represent it by using the histogram, then it will be like too much crowdy if it is more than 10 class. And if it is less than 5, then it will be too less for drawing the decision, for understanding or making a decision. So from 18 to 22 years, how many people we have? That is the frequency. From here, from this, suppose this is 34. So 34 is where? 34 is here in this group. So you give a line here. Then 67. 67 is where? 67 is here. So you give a line here. Just one line. Just one line. Then 40. 40 is, this is 40. 40 is here. Then we give 72. 72 is here. Then we have 37. So 37 is here. Then we have 33. 33 is again here. Then we have 42. This way we will continue and we will find out the frequency. After coming this 40, then we will count how many bar we have here. Then we will just write 11 bars we have here after doing all this thing, and then you will see automatically this number will come. This is the frequency. This frequency means between 18 to 22 years there are 6 people. Between 23 to 27 years there are 10 people. And what is this in terms of percentage? This is the percentage, and the cumulative percentage means this, then this plus this. Cumulative means add. If you add all the number, then what you have. So this plus this equals to this. Then this. If you add all of them, answer is this. Then the whole thing up to here, if you add, answer is this. This is the cumulative. Okay? Or you can say that this plus this equal to this. Cumulative. This is cumulative percent. And if the question is cumulative frequency, then how can we do it? Cumulative frequency. So first one is 6. Then cumulative frequency means now we have to add 6 plus 10. That is 16. Then next one will be 16 plus 14. 16 plus 14. So it will become 30. So 30. This way. This is called cumulative frequency. This is cumulative percentage because we have done it here from the percent, but we can do it from the cumulative frequency also. So now this chart is made. From the chart we can now make the frequency. This is the histogram. We can make the histogram here from 17. So from 17.5 to 22.5 because we have this continuous thing. Just we go for one decimal, like 0.5, we take 0.5 before and 0.5 after, just to make it continuous. So 18.22 is 17.5 and then 22.5. So between this we have this much people. We have 6 people here. 6 people. Then in the next group we have this much people, 10 people here. Then we have these people here. This way we can continue. We can say that 37 to 42. So 37 to 42. This is so we can say 37.5. So 38. So 38. So this line is 19 people, and we can see that this is the highest bar here in our chart, which is this is 20. So 19 is here. One very important difference, like why we said that this is 17 point or 22.1, very important difference between this figure and this figure is, you see, this figure is discrete. There is a gap between the bar here, because this is the datas are qualitative. The datas are qualitative, and here the datas are quantitative. Datas are continuous. Okay. In this case, we have considered, like suppose in this case it is considered that the age is 34, but some people may have 34.5, 34.2, which is ignored here. Okay, so we can go for better accuracy here. Anyway, so this is the representation of this data to this histogram. This box, this diagram here is called the histogram. Of course, if we take number of classes less, then the number of these bars, they will be less in number. Suppose if we take 8 class, then it will be 8 bars here, like that, and the process will still remain the same. Now there are some other ways by which we can represent this quantitative data. One way is called dot plot. This is the dot plot. Basketball player's height. So 5 feet 2, there is 1 people here. Then 5 feet 4, there are 2 peoples here. So on the bar, on this number line kind of line, we can actually just put dot, and then this will represent the data. This is called dot plot. This is called dot plot. If you plot it this way, this is called dot plot. So 5 feet 8 is the maximum number of people we have here. 1, 2, 3, 4, 5. So 5 people are 5 feet 8. Okay, this is the height. So we can just put the dot for that. This is called dot plot. Another way is called stem and leaf diagram. Okay, this is called a stem plot. This is the stem plot. So in this stem plot, we have one line for stem and one line for leaf. How is that work? Let me show you that. So you see, this is 15. This is 16. So 15 and 16. So you see, we can write it this way. From this 15 and 16, 1 is common, so we can write 1 here. Then we can give some bar here. Then 5 and then 6. So it will represent 15 and 16. Then from this 2, all the numbers are here within this 20. So this 2, then 1, 3, 3, 1, 3, 3, 6, 6, 6, 6. Okay. So this is a method how to place this here. This is the stem. This is the leaf. We can represent the data this way also. Okay, and here we can say that 1 bar 5. This will represent 15. Okay, just to mention it. Just one value we can mention in separately, so that there is no confusion for any new reader. Okay, suppose 41. This is actually 41, not 4 and 1. Okay, 4 bar 1. So it represents 41. It represents 41. It helps us like to avoid writing all the same common thing again and again and again. So it helps us this way. This is called stem and leaf diagram. Next one is frequency polygon. So So we have it here, class limit. This is a new data. Suppose from here to here, from here to here, some data sets are given. Suppose the frequency is 2, here to here frequency is 2, etc., etc. This way continue. This is CF. CF means cumulative frequency. Cumulative frequency. So this is 2, then 2 plus 2 means 4, then 4 plus 5 means 9, then 9 plus 15 means 14. Cumulative means we have to add them again and again. This one, then this one and this one, then in the next line all 3, then the next line all 4, then in the next line all 5, like that. And we put it here. This is cumulative frequency. Then the midpoint of this class, this is the midpoint of this class. This is the midpoint of this class. So midpoint is here, and for this midpoint we have what? We have frequencies 2. Then for this 44.35 we have again 2. Then 45 point, this midpoint 47.35, and this is somewhat here 5, below 6. So it is 5. The next one is also 5. The next one is 12. Next one is 12. 12 is here. If we draw a line, it will be aligned, directly aligned there. So this is called the frequency polygon, and there is another one which is called cumulative frequency or ogive curve. Ogive for cumulative frequencies. For the same data, this is the cumulative frequency. So in our previous chart, we used this box here, but in the cumulative frequency, we will be using this cumulative frequency, this box here. So we have this value here. This one is starting, then 42.8 or 85, 42.8. So for this one we have 2, then we have 4, 45.85, then we have 48. We are taking for the cumulative frequency curve, we take the highest value of the class. We take the highest. We will summarize it in the next slide. In another slide we will summarize it. So we take the highest value, but in the frequency polygon, we actually, in our previous graph you have seen, we take the midpoint. So there are rules for that. So for 42.8 we have this value. 42.85 actually came from the actual data. Let's consider it's 42.8. Then 45.8, then this other data. We take the highest point. And then these are the cumulative frequency. This is 31. This is 35. So you see 31. We take the cumulative frequency as this one. You see this if you watch the cricket, then you will see that this kind of chart for representing the run scored by some team. You will see this kind of lines by them. So we have this. We see this in the sports and other things. This kind of graph, which is called ogive curve or cumulative frequency graph. Also, this is called cumulative frequency graph or ogive graph, ogive or ogives. So both same name. Now we have. This is actually the last slide, and these are the works. Try to do some works, try to construct histogram, frequency polygon, and ogive curves from this data. But we can actually discuss them in our class time also. So this is another chart for doing all these maths: histogram, frequency polygon, and ogive curve. Then here, as I said, for histogram use the lower class limit. For frequency polygon use the midpoint. For ogive curve use the upper class limit. Okay. So for upper class limit is this one, and then for midpoint we will need for frequency polygon, and for histogram use the lower class limit. Lower class limit means in this case 151, 101, etc. Okay. So this if these data are bigger, or if all these data are different or problematic for you, you can just look at the other maths also, or any other data. Just the necessity here is to practice and try to get your graph, if you get your graph or not. That's the purpose of this maths. Alright, so that's all for today, and thank you all. Thank you very much. Bye everyone. See you all in the class. Bye bye.